Okay, in this video we are going to talk about linear combination and span. First off, let's start with the example of linear combination and figure out what it is. So let's say we have a set of vectors. We got v1, v2, v3, and keep going to vn. And those vectors are in the subspace of all real numbers of n. So to find, if we want to make a combination of those, we can add them all together. And to find any linear combination of those vectors, what we're looking for is, can we multiply constants, say C1, can we multiply those by our vectors and still be in that subspace Rn? So plus and C2, V2, plus C3, V3, and all the way to Cn, Vn. And those all should be in that same Rn. So let's try an example. Say we have a vector A, which is 1, 2, and we have a vector B, which let's say 0, 3. If we have those two vectors, what are linear combinations of those vectors? So all we're really going to be doing is finding the C's that we can put in front of our two vectors. So we got C1 of A plus C2 of B. And those, any value we plug into these will be a linear combination of the vectors A and B. So we could do 0 of A plus 0 of B. It's a valid linear combination. I mean, that's going to give us 0, 0, the 0 vector. Or we could plug in, let's say, 2 for C1 and of A plus, let's go, 3B. So that's going to give us 2 times our vector A plus 3 times our vector B. And if we solve that out, we're going to have 2 minus 0 times, and 4 minus 9, which is going to equal 2 and negative 5, which is a linear combination of our vectors. We can call that C, vector C. So C is a linear combination of A and B. And we could also do another one. We could do 3 of A plus, say, a negative 2, switch it up, of B is equal to our C. So we have 3 times A plus negative 2 times B. That's going to give us 3 minus 0 and 6 minus 6. That's a 6, which is then going to give us 3, 0, which is also a linear combination. Linear combination. So that's how you do linear combinations. Now we're going to move on to span. So say you were posed with the question, given A, vectors A and B, is C another vector in span with A and B? And to span, what span is if you can find a linear combination of A and B, which will give you C. If you can find that linear combination, then C is in span with A and B. So to solve a problem like this, let's just start out how we're doing linear combinations. Let's say, so we need a C1 times A plus a C2 times B, and now we're looking for, can we find any combination of the C's with our A's and B's that will give us our C vector. So let's say C1 times this vector plus C2 times B is equal to 4, 6, our C. Now if we can find a C1 and a C2 that satisfy this equation, we know that C is in span with A and B. So to solve this, let's just take the first component, the first row, so we do C1 times 1, this one right here, plus C2 times 0 is equal to 4. And we do it again for the bottom row. We have C1 times 2 plus C2 times 3 is equal to 6. So to solve this system, we can, well, here, let's rewrite it. Let's say C1, because we know we have 1 C1 plus 0, so we don't have anything there, is equal to 4. And we have 2 C1 plus 3 C2 is equal to 6. So with this, we have a system, and we can solve it. This one's very easy. So this one will give us C1. We know that C1 now, C1 is equal to 4. Using that information, we can plug that C1 in right here. We know that the 2 times C1, so 2 times 4, plus 3C2 is equal to 6. So then from there, I mean, we just solve it out, basic algebra. 3C2 is equal to, we subtract the 8, 6 minus 8, which then will give us 3C2 is equal to negative 2. So then from there, C2 is equal to negative 2 over 3. So we have found our linear combination of these two vectors. So we have proven that there is a linear combination of A and B, which can give you C, so then C is therefore in span with A and B.